Okay, so I would just want to do some brief explanation with regards to L-Hospital's rule. Now, you'll find that there are many functions which we cannot find limits by direct substitution, and those functions we may then be able to find their limits using L-Hospital's rule. So you'll find that with L-Hospital's rule, it does have some conditions in which we can only be able to apply it. And perhaps just to give you a simple definition of L-Hospital's rule, is L-Hospital's rule states that if, for example, we are given uh, functions, f of x and g of x, and also as well a limit uh, a. It follows that the limit of a function f of x over g of x as x approaches a particular number a, this will be the same as the limit of f of x, f prime of x over g prime of x as x approaches a particular number a, which is also the same as the limit of f prime prime, which is the second derivative over the second derivative of g, as well as x is approaching a, and this continues until it continues in that manner, like that. The second derivative, the third derivative, and the fourth derivative, like that. But this is only true, or this is only correct if and only if and only if we have the indeterminate, if we have the indeterminate forms, number one, 0 over 0, and number two, infinity over infinity. So each time we try to substitute into the function and we get the indeterminate form 0 over 0 or infinity over infinity, we can then go ahead and find that limit using L-Hospital's rule. Take, for example, a very good example which we can use to apply L-Hospital's rule. Take, for example, if I say find the limit of the function, or rather, let's find the limit of sine x over x as x is approaching 0, like that. So you'll find that if I substitute where there's x with 0 into this function sine x over x, sine 0 would give me 0, and if I put 0 in the x, I get also a 0. So this is what we are calling the indeterminate form. And once we get an indeterminate form like this, then we are able, or we are at liberty, to use L-Hospital's rule. And if we are to use L-Hospital's rule, that means this limit that we have here, we can express it now as the limit of we differentiate now the numerator, as we saw in the definition I just gave you here. So if we differentiate sine x, we're going to get cos x over the derivative of the denominator. If differentiate x, we get 1. And remember, x is still approaching what? 0. And now if I substitute the value of the limit, cos 0 is going to give me 1 over 1. So you see that this limit becomes 1. So therefore, the limit of this function using L-Hospital's rule is equal to 1. And we only applied L-Hospital's rule because we had an indeterminate form 0 over 0. So it's very important for you to note that each time you have an indeterminate form, either 0 over 0 or infinity over infinity, That is the condition for applying L'Hospital's rule to find the limits. So we can have many examples. Again, if maybe I can take away this to give us example number 2. Let me just erase this. Suppose also you're asked to find the limit of, say, 1 minus cos x over sine x as x approaches 0. So if I put 0 in the numerator, this will be 1 minus cos 0. I know cos 0 is 1, so that will be 1 minus 1, which gives me 0. Sine 0, if I put 0 in the denominator, sine 0 is what? 0. So that means I am at liberty to use L'Hospital's rule to find the limit of this. So what do? I need to differentiate the numerator and differentiate the denominator as well. So if I differentiate the numerator, differentiate 1, that's 0, differentiate minus cos x, we are going to end up there with sine x. And if I differentiate sine x in the denominator, I get cos x. And remember, x is still approaching what? 0. Now, if I put 0 in the numerator, what am I going to get? 0. Put 0 in the denominator, what am I going to get? 1. And what is 0 divided by 1? That is equal to 0. So that means the limit of this function is actually equal to 0 using L'Hospital's rule. So that's another practical example where we can see how to apply L'Hospital's rule. Now, maybe I can give you another example as well. If we are asked to find the limit of the following, find the limit of, say, x squared over x squared plus 1 as x approaches 0, like that. Sorry, x approaching infinity. Let's put infinity for us for a change. So if we have x approaching infinity, if I substitute infinity in the numerator, what am I going to get? Infinity squared, that is infinity. The same thing in the denominator. If I substitute infinity there, that's infinity squared plus 1, and that gives me infinity as well. So I have the indeterminate form infinity over infinity, which is also a precondition for me to use L'Hospital's rule. So what do? I go ahead and now apply L'Hospital's rule. You differentiate your numerator, you get 2x. You differentiate your denominator, you get what? 2x, and x is approaching what? 1. So x is approaching infinity, like that. And I know that 2x over 2x is the same as 1. So this is now the same as the limit of 1 as x is approaching infinity. And we know that the limit of a constant is that very same constant. So in other words, we have a theorem which says the limit of any particular number a as x approaches any particular number, say c, this would be equal to a. So the limit of 1 is equal to 1. So you can see we have applied L'Hospital's rule here to find the limits. So in the next video, I will do more questions where we can, with different scenarios where we need to apply L'Hospital's rule, and how to make sure that that condition also is met as we are applying L'Hospital's rule.